Okay, so hey guys, I am back with my YouTube channel. It's been a long time, and I have a news. I have got MacBook Air latest, not latest. It's M1 edition, and M2 just came out. So I was in a hurry to get a laptop, and I got it, and I got M1. Though it's an older edition, I had to get it. Uh, so it's been a long time, and you must have noticed that I look a bit shredded and I lost some weight. Yeah. So without wasting any time, let's get into it. And I want to share a few things before getting started. I need to set some goals and talk with you regarding why exactly am I streaming right now. It's like you can see the time here. It's like 11th of August, and it's like 2:23 a.m. in the morning, and I need to go to my home in the morning, like 6 a.m. train I have to catch, and I am still awake, not sleeping. So there are few things I need to talk to you regarding a few things, right? So firstly, why I'm streaming at this hour? I need to be to stay woken up, and to catch the 6 a.m. train. I need to stay woken up, and I will go to sleep if I don't do something. And if I am doing something, it must mean that it has to be productive. Like, it's my time, it's the crucial time of the placements right now, and that this time needs to be utilized, like properly utilized. So it's August, and the companies have started coming in. I have given the test for Intuit, I have given the test for Infosys, I have given the test for Gamescraft today only, and not today exactly, I can say 10th August. Like, it happened that it the test was in the evening, and I also gave the test for Airbnb, and I'm pretty I don't get demotivated. Like, I have to tell you that I don't get demotivated easily. If I don't know the questions, I don't know it. I don't stress about it that I don't know how to solve the questions, and I need practice. I know that I need practice, and it will take some time to like get the niche of the placement tests that are going around. I have also decided that I won't be applying for the non-tech positions, and will be mainly focusing on software development part, and mainly data structures and algorithms, and that's it. So why streaming? Streaming because of two reasons. I need to get like going. I need to get smooth with my problem explaining skills. Like, people can solve it DSA questions, but they can't explain it. So I need to know how to explain. I need to think clearly. Like, I can't and I need to speak English to explain it to the interviewer. I need to have a clear mind. So if I'll be talking to you guys, like if I am talking to myself right now, if I say, so I have a medium where I can check, like how I was speaking. I know how I am speaking, but I need to be confident to speak to the interviewer. A week back, uh, last Wednesday, I will say, last Wednesday, our placement symposium took place, and in that I had very low response in my HR interview. Like, I am pretty much underconfident when I am speaking something about which I don't know. So I need to know things, and I need to know how to be confident and how to stay calm and say what's happening in my mind, what's running in my mind, what I am thinking about the current problem and all that stuff. Okay, so so let's get right into it. Let's I'll share my lead code. We'll start with lead code, and this is the stream running lower than the recommended bitrate. The bitrate is lower, so the stream is not running or what? I don't know what is here. What's happening here? Let me. Okay, the stream is running perfectly fine. If I say 1080 pixels, okay, and if I unmute here, what's happening here? Let me. Okay, so it's perfectly fine, and let's get right into our lead code and continue and start this placement series, like placement prep series on live stream. Like I need a buddy coding, I need a buddy to start coding, and I am considering myself as a buddy. My YouTube channel, although these videos are not listed on YouTube, these will be kept to myself, but they will be out there when I'll see these videos after 2 years, 3 years, or even after 2 months. When I'll be placed, I'll laugh, and it will be fun. So here is my late code profile, the Raghav Gupta. I have been solving quite for some time now. I started in July, from July, like July 6, and have been solving quite a lot of problems. And you can see the number of submissions I have done. Like you can see that. So talking about this contest rating, I recently gave this contest and participated in this weekly and bi-weekly contest, and here it says -30. Okay, so this -35, I guess this was because of the wrong submissions, multiple wrong submissions which I gave, I guess. How do I get wrong submissions? Okay, so never mind. We'll talk things later. And this is weekly and bi-weekly contests, and today Code Chef contest also, we took part in Code Chef contest, and there also we achieved a rank, we achieved a negative rating. And well, that's life, and we'll, I guess, proceed to the problem solving and jump. Currently, I was following this SD sheet by Striver, and it's on his website, Take You Forward, and we'll continue from this sheet. Okay, so this arrays part 1 is done. This Pascal's triangle problem, I have solved this problem earlier. This is a basic DB problem, and I don't want, I basically what I am doing is this link 1 and link 2. Link 2 are of lead code links, and link 1 are of Code Studio or GFG, and these are the solutions of Take You Forward YouTube channel by Striver Raj Vikramaditya. And the Pascal's triangle is a basic problem of DB. I have solved this problem, but I have not marked a tick here because I need to watch the YT solution, and I'll do that when I'll be revising the DB part. Okay, so I will start continuing. Also, I'll continue with I don't want to continue with arrays because I spent quite a time at these first two topics, and I'm not uh, opened up with the other topics. So this, by the way, this merged two sorted arrays without extra space. I have solved the lead code version, but the version of GFG, I guess, if I click here, if I open this okay, so coding ninjas Code Studio platform. So this problem, the merging of two sorted arrays without extra space, this is basically a problem where the problem on lead code is like the array 1 has extra space at the end, which is equal to the space of array 2. So it will be like merging, will have to take the elements of array 2 and place them at the end of array 1, and then we'll have to sort so basically the 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 basic implementation of this problem at lead code would be in that way. But the problem on this Code Studio version is that we are given an array 1, and we are given an array 2, and we have to merge. Okay, so here also the Code Studio version is the same. I see the Code Studio version also the same. Like I was just explaining this, that the size of array 1 is like 3, and the size of array 2 is 2, but array 1 has 2 elements extra corresponding to the size of array 2, which have to be placed here. So 3 will be placed, 3 6 9 is there, 4 and 10 will be placed, and they later, after sorting, 3 4 6 9 and 10 will become the new array which we have to transform. Okay, so so uh, but the problem but this problem, if I open this problem, merge two sorted arrays, so and this problem is a bit different. Here we have array 1 and array 2 without any extra space at the end of array 1, obviously, and we have to change the sequence of elements, and we have to assume that array 1 ends at the end of array 2, like array 2 is placed at the end of array 1, and we read them as a single array. Like we have to club up the elements and sort them, like 2 goes here and 4 will go here and 8 will go, like you can see the output here. Like array 1 has to, array 1 and array 2 have to have the sorted elements in the sorted order in place. Like this is the problem, this which is a little bit more trickier as compared to the problem which we have the links to. Like this problem is pretty simple. Like we have to insert pick up these elements from the last element, and we have to place them one by one. Like we'll start use two pointers. One will be pointing at the last of array 1, and another at end of array 2, and will maintain an index from the last. So whichever the element is greater from the 9 and 10 will be placed at the end of the array 1. So 10 will be placed here. Later when the 10 is placed, we'll shift the pointer to next element. So 4 comes and we'll compare it with 9. So after comparing 4 and 9, 9 is the greater one, so 9 is placed here. Then we'll check with 6 and 4, 6 is the greater one, 6 will be placed in this place. And after this we'll check with 3 and 4, 4 is the greater one, 4 will be placed here, and there come, and the last element 3 remains. So 3 4 6 9 10 will be the answer. So this is pretty simple. Like we can, what we can do is the basic approaches. We can pick the elements of 4 and 10 and place it directly at the end of array and sort it. But the approach which I just told you verbally is that we maintain a pointer here, we maintain a pointer at here, and whichever element is greater, the pointer will decrement, and the maximum the element will be placed at the end at the last index, and the last index will decrement. So this is a pretty simple problem, and but the version of this problem which we have to solve is a bit different, and this version will be available at GFG, Geeks for Geeks, and I'll not get into it. So basically I was saying that I have solved a version of this question, but not exactly, so I have not marked this. So okay, so I'll for the time being, for the time okay, and moving on, this question: find the duplicate in an array of n plus 1 integers. This question basically tells us that there are n plus 1 numbers, and those n plus 1 numbers only contain numbers from 1 to n. Okay, the we have given an array of n plus 1 size where each element is between 1 to n. So when each element is between 1 to n, and there are n elements, so one element which remains ought to be one element which repeats. So the basic approach of finding the duplicate number is, pick up all the elements, throw it in the map, whichever element repeats, that would be the duplicate. But the problem here is we have to uh, uh, allocate a space. It will take O of n space complexity, which is not a good solution for us. So what we'll do is we'll uh, we'll start what we'll do is we'll use a cycle detection algorithm. Okay, like okay, here is an approach used is sorting without space complexity, but sorting itself can take log n of n log n time, and sometimes sorting also takes extra space of log n. So here see space time complexity of n log n plus n. Reason n log n for sorting the array and O of n for traversing through the array. So we'll use another approach which will be, okay, duplicate element is 3. Okay, so this is basically frequency arrays. Basically, frequency array is basically a map approach. So we'll place all the elements in a map, in an array, and whenever we have to increase a frequency, we'll return the array, the number. Okay, so the this is all. This approach uses O of n space, though the time complexity of O is O of n. So finally, linked list cycle method, fluid detection algorithm. So what this basically means is that we are at 0th index, and our number is 2. So when we go from 0th index, we see this number. This number is 2. This means we go to the second index, which is 9. When we see 9, we go to 9th index, which is 1. When we see 1, we go to 5th index, which is 5, and we go to 5th index, which is 3, and later we go to 6, and after that we go to 8, after that we go to 7, and after that we go to 9. And once we reach the 9, we see that we get back to this position. So what we can do is that we can replace these elements. Like we can modify these elements when once we reach a position, we take the absolute value of that position, and once and that will have, for that we'll have to ensure that the elements are all positive. So if whenever a negative element occurs, it means that we have already reached that index, and we can directly say that this element repeats. Like we have reached 9 from 2, and we have reached 9 from 4, and we have reached 9 from 7. Okay, so that way. But that is a vague approach, because we can't use that approach in a practical setting, because we have to modify our array, and that is not like and that is not feasible to modify our given array. So instead, we we cycle through it. Like, we start point like a linked list cycle algorithm. We use this Floyd cycle algorithm, linked list cycle algorithm. So as we can see that 0 to 2, and after that 2 to 9, we can see here 2 to 9, and 9 to 1, okay, 1 to 5, and here a cycle forms. Okay, so once we reach 9 again, and we reach 9 from 2, and we reach 9 from 7. Okay, so we don't reach 4 here, and so we don't reach 4 in this case, and so the 4 is not involved in the cycle. So what we can do is, in this question, in this method, what Floyd cycle algorithm does is, we start two pointers, a slow pointer and a fast pointer. Slow pointer increments by a unit space, and fast pointer increments by double the size of the unit space. So slow pointer will go from 2 to 9, and at the same time fast pointer will go from 2 to 1. So by the time the slow pointer reaches 5, the fast pointer would have already reached 2 to 1, 1 to 3, and 3 to 8. Okay, so our slow pointer reaches 9. At that time fast pointer reaches 1, slow pointer reaches 1, fast pointer reaches 3, slow pointer reaches 5, fast pointer reaches 8. So that way we'll at a particular point, when we'll be rotating around the loop, there will be a point when slow and fast pointer meet. Because we are in a loop, they ought to meet, because fast pointer is moving at double the pace. So here slow pointer is at 5, this is at 8, we go to 3, this goes to 9, we go to 6, this goes to 5, we go to 8, this goes to 6, and we go to 7, and this goes to 7. So finally the slow and fast pointer meet at 7. So understand this point, that once we meet at 7, we break the loop and store the value as it is. We pick up the fast pointer and make it point back to the starting of the array, starting of our array, that is 2. So at this point of time, the intersection, the looping, the point of start of the loop is equidistant from the starting and the point where slow and fast pointer meet. So we iterate linearly and with equal paces from slow point along with slow and fast pointer, and reach and once the slow and fast pointer are equal again, we'll get the element which we need to return, and in this case 9. So we are at 7, the slow pointer is at 7 and fast pointer is pointing back to 2, and we increment 1 and the both pointer reach 9, and so 9 is our answer. So this is represented in this way. Here we can see that the slow and fast pointer meet at 7 after looping around the loop, and we reiterate, we make fast pointer point to starting of the node, starting of the list, and then start the iterations again, and they meet at a common point. Okay, so intuition behind this is that we travel a distance, and so the intuition behind this is that the fast pointer moves at double the speed, and if we say that the fast pointer covers a distance from the starting to the point of intersection, and the point of intersection to the end of the loop is x, so the slow pointer only covers a plus a minus x distance. So this basically means I seriously need to get a writing, like to show you how what I want to say. Like I can write it in my copy, obviously. Like if I say that our our fast pointer goes around the loop, and it obviously covers a distance first, and then covers x distance, and then covers a minus x distance. Alright, and the slow pointer at the same time covers a distance minus a distance minus a minus x distance. Alright, so what this means is that these two things should be the distance covered by slow pointer should be half of the distance covered by the fast pointer, because slow pointer is moving at half the pace of the fast pointer. So if we place them in an equation, twice of a minus a plus a minus x is equal to a plus x a minus x. So we'll say that twice of x is equal to twice of a, and x is equal to a. So basically what this means is that after the first collision point we move x distance from the starting and from to reach the duplicate point. Okay, so this got a not a bit, too much way. Since there is a duplicate number, we can always say that cycle we want, so slow pointer moves by one step, and the first pointer moves by 2 steps, and there is this. So the first collision is bound to happen. Let's assume the distance between first element and the first collision is a. So slow pointer has traveled a distance very fast, moving 2 steps at a time has traveled to a distance. Okay, slow and a fast pointer to collide, 2a minus a is equal to a should be the multiple of length of cycle. So length of cycle is a minus x plus x a. Place a fast point. Now we place a fast pointer to the start. Assume the distance between start and duplicate to be x. So now the distance between slow and duplicate should also be x, as seen from the diagram. And so now fast and slow pointer both should move by 1 step. So this question is solved in O of 1 space and O of n time complexity. Like O of n is basically traversing over the array, over our array once along the values of our indexes, obviously. So moving on, let me just check if the string is running fine. Basically traversing over the array, over our array once. Okay, this stream is running perfectly fine, and okay, this current bitrate is lower. Open widget. Stream bitrate of 4500k. Okay, I'll take that in mind. from next time. And let's continue. Let's I don't want to do more arrays. I hate arrays. I hate arrays. I legit hate arrays. I don't know what topic to start. I don't know what topic to like. I also have to cover these topics. OS, TVMS, computer networks. They'll fuck my life. They'll legit fuck my life. They will. What I will say. I also have to learn try graph and DP. I know basic DP. I don't know much. I only know how to solve factorial problem and not much DP. And true, I have solved some questions of DP, and but there I don't get the concept of DP. Like recursion with memorization is very clear to me, but what is what is the need of DP? Like okay, the space complexity will be reduced without using recursion, so that's why. But still, okay. So arrays. Let's get to linked list. Reverse a linked list. Basic lead code. Basic question. I have probably already solved it, but will I guess we should solve it again. If the head of linked list, reverse the list and return the reverse list. Reverse the list and return the reversed list. So we need to reverse this list. What we can do is okay, a basic approach which can be used. Just like a very vague thing is I can make this I can get the address of node 1, the first node, by putting a star sign. Star of node 1 is equal star of node 2 is equal star of node 1 will give the address of node 1. Okay, so I'll point node 2 of next to star of node 1. So that way we can, I guess, reverse the list. We can make a loop and say we can interchange the value. We can make node of 2 dot next to node of 2 point node 2 dot next point to node 1, but we have to make these changes in a reverse fashion so that we don't lose the list, but that way it will be a very hectic job. So what else we can do is that we can start iterating from loop 1 and go to loop 2. And while we are doing this, we can say that we store the next value of 2. We store the next value of 2. We in a next pointer, and make 2 of next point to 1. Okay, so that way we'll have an element next and 2 pointing to 1. So now next we'll use next and make it point to 2. Next we'll use 3 and make it point to 4. So the same thing is done here. We are using the 3 pointers: previous, current and third. So previous pointer, in this case head, the first node. If we start from head, previous node is head, current node is head dot next. So we what we'll do is that we'll make first point to null, if because we have to this will have to be the last element, this will point to null. So we'll make this amend previous dot next will point to null, previous dot next will point to null. Okay, so next what we can do is we'll iterate over this current. we'll iterate we'll iterate over this current node and keep iterating while this current node becomes null. So what we'll do is we initialized the third pointer, the third node, and we initialized it null. So now is the time we place the next value of current into the third node. So the pointer to 3 will be stored in third, and current of next will point to previous pointer. So 2 will point to first pointer, and then previous pointer will come here. So the first node is settled, and now we are at second position, right? So the same story goes for the second node. Here we'll make current point to third, and while the current is pointing to third, we'll say that the next node of current will give me the third node, and I'll say that the current node will point to the previous node. Okay, so previous node will change to current node, and current node will change to third node, and this way while we keep moving, and the last element comes 4 while current is 4. Okay, so while current is 4, we'll say while current is 5. Okay, while current is 5, current of third is equal to current of next, which is null. The third will become null, and current of next, this will be pointing to previous value, previous will be pointing to okay, so previous will be pointing to the current value, which will be 5, and current will be pointing to the third value, which will be null. So current becomes null, previous becomes this pointer, and we'll return this pointer, and it will have automatically pointed to the reversed list. And we have already submitted this code, and I will not submit it again and again. It was submitted on 22nd of July. This is a recent one, I'll say. Okay, no, not a recent one, I won't say that. It's already 20 days since I submitted this code, and it worked pretty well. So I'll make this code, show this code on Java on this Code Studio, which is a coding Ninja's platform. Okay, so linked list is so basically if I say that we can code and practice this question. Also I need to point that this edge case was handled when head would be null or the head of next would be null. That means if there is no node or there is only a single node, then we just need to return our node. Okay, so let's try implementing this again on our own. If head is equal to null, or head of next equal to null. Then we have to return head directly because there will be no other element. Okay, so now we'll make some linked list nodes, and this linked list node will be named the previous and will point to head. The next one will be named current and will point to head of next, and the next one will place to point to third, which is already null. So we iterate over the loop and we'll check current is not equal to null. Okay, current अगर null है. Now we'll store the next value of current in the pointer named third. Okay, we'll make the current node point to the previous node, and will then make previous node equal to current node, and third current will point to the third node, which will be the next node. Later we return the previous node because that would be the head of our final. Well, that would be the head of our final list at the end. Now if I need to handle this edge case, we'll say that previous of next is equal to null, and I'll say current of previous of next is null. And I'll run this. Okay, what the fuck? Why is it not logged in? Okay, so I'm using this coding ninja in my Safari, but originally I have logged in from the Google Chrome. सावरी सूरत को मोहन दीवाना हो गया. Okay, top problem list, driver defeat. Reversal linked list. I have already solved this question here, and still I'll submit this question and check if I have done the right code or not. Okay, let's check. Okay, compilation build. I can't make it point to. Oops. This needs to be a pointer, and guess it should work fine right now. Okay, perfectly fine. Best. So this was the reversed linked list problem. I'll mark it done, I guess. Now problem set me head of a single list. Write a program to reverse the linked list and return head pointer to the reverse list. Explanation: reverse linked list iterative. We'll use 3 pointers to traverse through the entire list and interchange links between nodes. One pointer to keep the track of current node, the second one to keep the track of previous node and change links. Lastly, a pointer to keep track of nodes in the front of the current node. Step 1. Okay, so basically this is an iterative approach which is discussed here, and time complexity of n and space complexity is O of 1 because we didn't use any kind of external space except the 3 pointers obviously. So linked list recursive. This approach is very similar to the 3 pointer approach. In the process of reversing, the base operation is manipulating the pointers of each node at the end. The original head should be pointing towards null and the original last node should be the head of the required linked list approach. In this type of scenario, we take the next pointer which will be initialized to head next and in future iterations. Okay, so I am feeling a bit dizzy even though there is a live stream going on. I feel like sleeping, and if I go to sleep right now it's 3 a.m. and I really want to wake up at like in an hour if I need. Like I should, I think, get some sleep right now. It will probably a very bad idea, but I'll have to do that. I'll have to figure a way out. Like, really hope. But I get I get a feel of the things which I need to be doing. Okay, so I guess that it will be it for the right time being, and we'll be doing more questions regarding the placement preparations because there will be a lot of things which need to be done. This linked list part and is mostly covered, I guess, and the middle also I have done. Like these are basic questions. Middle element of linked list is a basic question. We move from the array count from the array and we like count array and we move to the last of the array and again like iterate through the linked list for the end for the number of times and find the middle element as it is that. Merge to sorted linked list. Use method used in merge. Okay, and I also want to say that I don't exactly know the functioning of the sorting algorithms like what merge sorters, what quick sorters, what Bogo sorters. I don't know what these sorting algorithms do. Merge to sorted linked list, use methods to merge. I don't know, but I know how to merge to linked list. Like it will be similar in a similar but and a more easier way as compared to an array, because we can just simply cut the links and add the links, the next pointers, the next point, the pointers, and that's pretty much it. And I'll take a leave for the time being and see you guys in the next stream. This is this is your host Ducky Duck, Raghav Gupta, Androkutru, whatever you may call, you like to call me, and sayonara, and wish me luck that I wake up in an hour or so.